Assalamu alaikum students. Today our topic is related to Faraday's experiments or Faraday's experiment related to electromagnetic induction, or what I mean to say, the production of induced EMF in a coil. So what he did, Faraday performed a series of experiments. In all his experiments, what he did, he took an coil and he took a magnetic field. The magnetic field was with the help of the bar magnet, and in the some experiments he took a varying current, and because of that very current there was a magnetic field, varying magnetic field. And what he found out that there is production of induced EMF. Faraday performed the experiment, and where in all the experiments an induced EMF was produced. Induced EMF was set up or produced in the coil. What he did, he did one thing, that he changed the magnetic flux. He said that once there is change in the magnetic flux with the coil, so that can be done only once there is a relative motion, once the magnet is taken close to the coil or away from the coil, or if magnet is kept stationary, coil is taken away from the magnet or towards the magnet. And in this very experiment, he connected a galvanometer to the circuit. Why galvanometer? Because the galvanometer shows the microcurrent, the small currents same. Instead of ammeter, it is going to show the small currents. And when the magnet was moved towards the magnet, the galvanometer showed deflection in one direction. And when it was taken away from the uh, coil, he observed that there were deflections once again, but they were in some another direction. If we suppose that the magnet is taken towards the coil, then the deflections will be, if there would be a needle here, it will show deflection in this very direction. But when the bar magnet is taken away, this again shows deflection, but this is going to show now deflection in this very direction. So we can conclude that there is what, this can show only deflection once there will be current. So there is production of what, there is production of induced EMF, there is production of what, induced current in this very circuit with the help of what, varying magnetic field. So the deflection is produced only if there is a relative motion. It was also observed when this very magnet was kept stationary, there was no deflection produced in the galvanometer. So he observed deflection in galvanometer only when magnet was taken towards or away from coil. And it was also found that once there was a quick motion, once there was this very magnet was taken quickly towards the coil and taken quickly away from the coil, so it was found there was more and more induction. This showed quickly the deflection. So thus Faraday concluded that whenever there is a relative motion between the coil, whenever there is a relative motion between coil and magnet, and induced current and induced EMF set up, and this induced current lasts as long as there is relative motion. So he observed that deflection in the galvanometer only when magnet was taken away or towards the coil, and it lasts till there is a relative motion. If it is kept stationary, there will not be any change in flux linked with this very coil, and then this galvanometer is not showing any kind of deflection. Then in his second experiment, what he did, he took again one coil. This is the one coil, and to this very coil he connected a galvanometer, and this coil was called as the secondary coil. Let this be the direction of current, and close to it was another coil which was known as the primary coil. And in this very coil there it was connected to a varying current. So once current was varied here, there was production of what? In this coil is known as primary coil. Primary coil is that very coil which is connected to battery or cell, and this is called as the secondary coil, which is connected to galvanometer or uh, that is the galvanometer. In this experiment, Faraday replaced the bar magnet. In the first case, there it was a bar magnet, but he replaced the bar magnet by a current carrying coil, which was known as the primary coil. The second coil, which was placed very close to it, was known as the secondary coil, and it was connected to a sensitive galvanometer. Faraday observed that this very galvanometer showed deflection when primary coil was moved towards or away from it. So there was what was happening, the current which was in this very coil, because of that very current there was a magnetic field. Once that very magnetic field got linked with it, it sometimes got increased, sometimes got decreased. There was a constant magnetic field linked with it, because in this very first case the current was not changed. Once there was a constant magnetic field, now that very magnetic field, this very coil was taken towards it, so more magnetic field lines get crossed, so it was taken away from it, less magnetic field got crossed to this. As a result of it, as a result of it, this galvanometer showed deflection, but this deflection lost, still there is a relative motion. Thus finally he concludes that induced EMF and the current is produced in this very secondary coil once there is a relative motion between. So he here conclude, when there is a relative motion between current carrying conductor and the current carrying conductor, which was the primary coil, and the secondary coil. So once there was a relative motion between them, so it was found that the galvanometer showed deflection. So this was the second experiment, and we're gonna read about the third experiment and his finally two laws in our next topic. Till then, Allah Hafiz.